Okay, so today we're going to talk about sine and cosine graphs. So yesterday we did an activity, spaghetti trig, in which some of y'all graphed a sine. Alright, I don't know if this is recording right, but I guess we'll find out. So, if this isn't recording right, you might want to skip ahead until you get to slide 2 to show the sine and cosine graphs. I apologize for that. What we're going to talk about today is how you can change the amplitude and the period. So the amplitude of a sine graph is the distance from the sinusoidal axis to a high point or a low point on the graph. So the amplitude is how it stretches up and down. A cycle of a periodic function is a portion of the graph from one point on the graph to the point at which the graph starts to repeat itself. And then the period is how long it takes to complete that cycle. So I'll go through those words again as we kind of change them. So let's just look at example 1. If we graph y equals 4 sine theta. So notice that this is taking sine of theta. You could kind of insert these parentheses right here if you wanted to. This is going to take sine of theta and multiply it times 4. So it's not really changing sine. It's just going to take whatever, instead of being only a unit circle, now it's going to multiply that by 4. So if we think about sine, you got to kind of get these things memorized eventually, but we can think about it for a while. Sine is opposite, so when you start at 0 degrees, you haven't moved any opposite, because the opposite is your up to down. So right here, you haven't moved any opposite, so that's 0. Now when you go to 90 degrees, typically we say, well, we've gone up 1, so that's going to be 1. And then when you go to 180 degrees, you haven't moved any opposite, so again that's 0. 270 is down, so that's -1. And 360 is back to 0. So now it's saying, well, let's take that sine, because this was just sine, this column just represented the sine, and multiply it times 4. So 0 times 4 is still 0. 1 times 4 is now 4. 0 times 4 is still 0. -1 times 4 is -4. And 0 times 4 is still 0. So this is our degree. We're doing degrees right now. This is 0 degrees. We're at the 0. 90 degrees. We're up here at the 4. 180, we're at the 0. 270, we're down here at -4. And at 360, we're back to 0. So this represents 4 sine theta. So it really doesn't look that different. The only thing that really looks different is the y-axis. Instead of being -1 to +1, it's now -4 to 4, and that's because of that amplitude of 4. So that's what the amplitude is the amplitude is 4. It's not the total distance. This is called the total distance, and that's always going to be double the amplitude. But when you just say amplitude, that's saying how far up and how far down you go. Not up and down like together, but just how far up you go or how far down you go. And those will always be the same. Alright, so 3 cosine theta. So once again, I really want y'all to eventually have this memorized. But if for now you're kind of trying to memorize it and you're not sure how, think about cosine as your adjacent movement, and so you do have an adjacent movement at the 0 degree. Now we're in radians, sorry. At the 0 radians, and so your adjacent movement is present, so this is the 1. And then you're going to go to 0, -1, 0, 1. So 1, 0, -1, 0, and back to 1. So when we multiply it times 3, this is 3, 0, -3, 0, 3. So at 0 radians, I do have a height of 3. This is the pi over 2. I don't have a height, so that's going to be 0. At pi, I have a height of -3. At 3 pi over 2, I have a height back at 0. And then at 2 pi, I have a height back at 3. So the cosine is the one that's going to look like a U shape. Okay. And so the amplitude here is 3. Once again, if you wanted to talk about total distance, the total distance would be from the tippy top to down all the way to the bottom, and that would be 6. But the amplitude is just from the middle, I had to go up 3. That's the amplitude. Or you could say I had to go down 3, and that's still the amplitude. It's just 3, the single number. So in general, A right here is going to represent the amplitude. So the amplitude we denote with letter A. All right, let's go on. Sine function, some of y'all graphed a cosine function. So let me just review that really quickly. So sine of x. Now, if we're graphing y equals sine of x, then let's get a really clear picture of what we're talking about here. I'm graphing how x represents your angle. So x is the angles, and y represents, well, sine is opposite over hypotenuse. So this is what it equals to. So that's our y, because it's on the other side of the equal sign. So x is the angle, and y is the height that it's equal to. So let's talk about our quadrantal angles right here. So if you start at, we're going to do this in radians. If you start at 0 radians, so right here, if you're at 0 radians, if you notice this is a side-to-side movement, you don't have any up-to-down movement. So sine of 0 is 0. So I can go ahead and plot that point. So sine of 0 is 0. Now, if I'm here at pi over 2, that's 90 degrees, is pi over 2 in radians. If I'm here, now my sine opposite is 1, because I had a height of 1 here. Remember, we're just assuming that the hypotenuse is 1. This is called the unit circle because the hypotenuse or the radius of the circle is 1 everywhere. So your opposite is also 1 because you moved up with that. So at pi over 2, I'm up 1. Okay, at pi, 180 degrees, or pi, now your height is back to 0. And at 3 pi over 2, now your height is down at -1. And at 2 pi, if you complete the circle, your height is back at 0. So this is my sine parent function. And we could go ahead and just, we know that it's going to continue in this pattern. So if you wanted to make the other half, this is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So this is going to be the negative half. If you go backwards, pi over 2, so now we're here, you're again down 1. Negative pi, you're still 0, 3 pi, negative 3 pi over 2, and negative 2 pi. So if I can connect these, this is our sine graph. Okay, so a couple of things that you should note is that sine starts at the origin, 0, 0. And then it goes up from there. And it always has that shape to it. Furthermore, after you get your starting place, then you have these 1, 2, 3, 4. They're going to be called critical points, because if you go back to the picture, you have your starting 0, and then your 90 degree, 180, 270, finish the circle at 360. So you have the starting 1, 2, 3, 4 to complete a cycle. All right, let's do cosine really quickly. I'm not cosine, but if we have y equals cosine of x, so let's do radians again. Now, if you're doing cosine, cosine is adjacent over hypotenuse. And again, the hypotenuse is 1 because we're talking about a unit circle. Now, your adjacent is your side-to-side movement. So your adjacent is represented by a side movement of 1 here. So at the 0 degrees, remember we start at 0 degrees or 0 radians, you do have an adjacent movement. So now at 0, this is 0, we have an adjacent movement at 1. This is me just marking where 0 is. But this is where our dot is, because our adjacent movement is represented here. Now when I go to 90 degrees, or pi over 2, now if you look at this, from your origin, you don't move any adjacently. So your pi over 2 is going to be represented by the 0. At negative, or at the pi, you move adjacently -1. And 3 pi over 2, you're going to be back at the 0, and then 2 pi will finish it out. So our cosine function, I consider this to kind of look like a U. And so we can finish it off negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So it's going to be middle, down, middle, up. So that's our cosine parent function graph. All right, so let's go back to our notes. All right, so now we're going to do y equals sine 3 theta. Look at what is changing now. Now it's the number, there's a number next to the theta. Keep in mind it's typically y equals sine theta, where theta represents the angle, which is on the x-axis. If we multiply that angle times 3, something's going to happen. So if this theta is normally, we say it's normally in degrees, since this problem is in degrees, I'm going to talk about the degrees. So normally we say, well, 0 is an important one, 90, 180, 270, and back to 360. So that's why they've listed these out here. But that's what it normally is. And in this case, that normally is 3 theta. So what we're going to do is just solve for theta, or get theta by itself. So if if 3 theta is 0, then theta, well, divide by 3 is still 0. If 3 theta is normally 90, then in this case, theta is really just 30. If 3 theta is 180, then theta is 60 here. If 3 theta is 270, then now it's 90 degrees. And if 3 theta is 360, well, now it's 120 degrees. So rather than it being 90 degrees in this case, because that represented 3 times theta, now it's just 30 degrees. So look at these critical values. They already put them on the axis for you. So now this is 30, 60, 90, and 120, because this is changing those critical points. Rather than being 0, 90, 180, 270, and back to 360, when we get theta by itself, we change those to these. But still, this value is not changing, because if you notice, it's just sine of that number. So sine of the first one is still 0, and then we go up, back to 0, down, back to 0. So 0, we go up, then 0, then down, then 0. So we start at 0, then we go up, back to 0, down, back to 0. This represents one period. And in this case, our one period only took 120 degrees. And that is not coincidental that that 120 degrees is, if 3 theta equals 360, if you divide 360 by 3, you get 120. So the period of sine 3 theta is 120 degrees. And there's a critical point, which means this is the starting place, high, back to 0, low, back to 0. So it happened every 30 degrees. And that's always going to be, if you just take that period and divide it by 4, that's how we got 30 here. Because remember I said that after you decide that starting place and you have 1, 2, 3, 4 important points, it's the starting place plus 4. So don't just think it's 4. You got to start it and then do 4. Okay, so let's do a cosine one. So again, these are the normal critical points, but if we take those critical points of 0, pi over 2, pi, 3 pi over 2, and 2 pi, and now we're saying, well, that's going to be 2 times what theta should be. So 2 times theta is 0. Well, divide by 2, you still get 0. If 2 theta is pi over 2, when you divide by 2, you get pi over 4. If 2 theta is pi, divide by 2 and we get pi over 2. If 2 theta is 3 pi over 2, then now we have 3 pi over 4 and just pi. If we think about cosine, cosine is the adjacent movement, so you do start with an adjacent of 1, then we go to 0, backwards, 0, back to 1. So this time it's making us label the axis, so let's go ahead and label that. We're still starting off at 0. Sometimes you want to label that. I think it's generally a good idea to label the 0 if you use the 0, which we did here. Then we have pi over 4. Then we have, I'm just going to make this bigger. I can look back. So this is pi over 2. This is pi. This is 3 pi over 4. Did I skip one? So I should have my starting place, 1, 2, 3, 4. Oh yeah, I'm sorry, right here. This isn't pi over 2 and then pi. That's where I messed up. So I thought I could do it without looking. I can't. So it goes pi over 4, then pi over 2, then 3 pi over 4, then pi. So pi over 4, then pi over 2, that's right, because this is 1/4, 2/4, because that's half, 3/4, so 3 pi over 4, and then the pi. And for cosine, we always start up and then make the U shape. So this is my cosine graph. Okay. So the period for this one is, well, it took us pi to finish that. And so there's a critical point, take that pi and divide by 4, pi over 4. So in general, the period for y equals cosine b theta. Now this is the hardest one to remember because you're going to be tempted to say it's b, and it absolutely is not. Keep in mind that it's normally a full period is 360 degrees or 2 pi in radians. But what we do is we take this number that's right here and we divide it by what it normally is. So it's not that B tells you your period, it's that B gets you your period. So you can either do, if it's in degrees, you'll do 360 divided by B, or if it's in radians, 2 pi divided by B. And so then in order to get the critical point, you're going to take that period that you just figured out and divide it by 4. Because you got to split that among 4 places evenly. So this is period over 4. All right, let's go ahead and do some examples. So we want to sketch 2 complete cycles. All right, so this number right here is the amplitude, and this number right here helps you get the period, and we are in degrees. So now we can see, well, let's write some things down. This is cosine. Cosine starts at the up. Remember, it's the U shape. We just noted that our amplitude is 6, so we're going to go up 6 and down 6. And then our period is going to be affected by this 5. And since we're in degrees, we can say that the period is going to be 360 divided by 5. This is non-calculator if I didn't say that already, so if you need to come over here and do this. 7 and 2. So our period is 72 degrees. Now we're going to have to get all of these critical points. So let's take 72 and divide it by 4 to get all those critical points. Nope, just one. And that's 18. So critical points is every 18 degrees. Alright, so let me refresh what I did. I said this is cosine, so that reminded me that it looks like this normally. The 6 represents my amplitude, and the 5 leads me to get to the period. Remember that the period is not 5. Oh my gosh. But you have to say, well, normally in degrees, my period is 360. So normally it's 360. I divide it by that 5 and I got 72. That's my period. Then because we're going to have to get those 4 critical points, I took 72 and divided by 4 to get 18. Okay, so let's go ahead and start now. So, as pretty as you can, make a XY. I am better at this not on the computer like this, but that's okay. We are going to start at the 0. Tomorrow we're going to start going left and right, so you're not always going to start here at the 0, but for today we are going to start at the 0 because we're not moving left and right yet. We know we're going to go as high as 6 and down to -6. And we also know that we're going to have 4 ticks to reach 1 period. So this is going to be 1 tick, 2 tick, 3 tick, 4 tick. Remember that you have your starting tick and then 1, 2, 3, 4. So that first one is 18 degrees after we started at 0. So this is 18. And then add another 18, that's 36. Add another 18 is 54. And add another 18, that's 72. Which, if you notice, 72 matches with the period of 72. So I know at this point I should complete 1 period. Let's kind of make a note right there of just this is where 1 period is going to complete. But it did ask for 2 complete cycles. So let's go ahead and add 18 4 more times, right? Because now this represents my starting place for the second period, and I'm going to have 1, 2, 3, 4. So you can go ahead and mark 1, 2, 3, 4. And if we add 18 again, that's 90. Add 18 again is 108. Add 18 again is 126. Add 18 again, 36, 44, 144. And so this will be the ending place of my second cycle. Alright, cosine starts at the up, then it goes to the middle, down, middle, up. So we're going to start at the up. we go to the middle, down, middle, up. That's one cycle. Now, if you wanted to go ahead and graph that cycle, you could. Now we got to do the second one now. So the second one, you still start here. We start at the up. Then you go to the middle, down, middle, up. So you start at the up, middle, down, middle, up. This represents a second cycle. Okay, and that's our 2 cycles of this cosine graph. Alright, let's go on. Y equals 8 sine half x. So, let's go through all those steps again. So the first thing that I did is it is definitely worth your time to note that you're starting with sine. Sine looks like the S shape, which is actually how I remember it. Sine is the S. That's really pretty helpful. Which means we start at the middle, then we go up, middle, down, middle. Now, what else do we need to know? This 8 tells me the amplitude is 8, so I'm going to go up 8 and down 8 from that middle point. And half, we're in radians, half gets me to the period. It is not the period, but it gets me to the period. In radians, my normal period is 2 pi, and I divide it by that b value, which is half. Now you can do this however you like, but the easiest thing to do is, in order to get rid of a denominator that's a fraction, you flip that fraction. So let's make it 2 over 1, and this is that magic number of 1 I talk about a lot. So I'm really just multiplying top and bottom times 2, and by doing that, this cancels with this, and so 2 pi times 2 is 4 pi. So the period is 4 pi, and then every critical point is going to be that 4 pi divided by 4. It's just pi. Okay. So you should copy that down if you don't already have it down. I'm going to move it to the side so I can graph. Alright, so make our x and y axes. We are starting at the 0, and then we're going to have 1, 2, 3, 4 critical points. This will be the end of our first period, but then we're going to have 1, 2, 3, 4 more critical points. This will be the end of our second period. And each of those critical points is different by pi. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So this is sine. Oh wait, I haven't done the amplitude. The amplitude is 8, so I go up 8 and I go down 8. Okay. So for sine, I start at the 0, and then I go up, middle, down, middle, up, middle, down, middle, and then we make our shape. Alright, let's go on. 2 cosine 4x, and we're in radians. So this is cosine. Cosine is that U shape. The amplitude is 2. The period in radians is 2 pi divided by 4, which is pi over 2. And my critical points is take that pi over 2 and divide it by 4. So in order to reduce this fraction, I am going to put 4 over 1. So now I can do 1 over 4, 1 over 4. This cancels with this, and I get pi over 8. So my critical points is pi over 8. On this, I'm not really that particular if you don't reduce your fractions, so that's going to make it a lot easier on you. So make your xy. We're starting off at 0. And then I'm going to have 1, 2, 3, 4. This will be the end of the first. 1, 2, 3, 4. This will be the end of the second. So I said you're not going to have to reduce your fractions. This is why it's going to be easier for you. Because if this is 0 and you add pi over 8, when you add pi over 8 again, I am perfectly fine if you just say that's 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. I didn't space these out very well, but 6 pi over 8, 7 pi over 8, and 8 pi over 8. Now, if you want to reduce, that's perfectly fine, but this is just a lot easier counting-wise if you just do this. Okay, our amplitude is 2, so I'm going to go as high as 2 and as low as -2. And since this is cosine, I started up, then I go middle, down, middle, up, middle, down, middle, up. And that's our cosine graph. Let me just make that a little bit better. That's not that much better. Okay, let's go on. Y equals 12 sine 3/2 theta, and we're back to degrees. So this is sine. Sine is our S shape, so that means we do middle up, middle down, middle. Our amplitude is 12. Our period back to degrees is 360 divided by 3/2. Okay, I have to do 3/2. I have to flip that to get rid of it, so that's 2/3, 2/3. So your job right now is to do 360 times 2/3. I think that the easiest thing to do is to do 360 divided by 3 is 120, and then multiply that times 2 and you get 240. You could do 360. You could say 360 times 2 is 720 and then divide it by 3. But I just think it's easier if you divide first because you get smaller numbers. Alright, and our critical points is take 240, divide it by 4, and you get 60. Alright, so here we are. Last problem. We start at the 0. We're going to add 60. So 1, 2, 3, 4. This is the first end of the cycle. 1, 2, 3, 4. End of the second cycle. 60, 120, 180, 240, 300, 360, 420, 480. And I go as high as 12 and as low as -12. Alright, sine is middle, up, middle, down, middle. So, middle, up, middle, down, middle. Up, middle, down, middle. And that's it for this section.